All right, guys, Mr. Antonucci here, and in this video, I'm going to teach you everything you need to know for Unit 1 in AP Calculus. This is dealing with limits and continuity. First off, let's talk about some key ideas. You need to understand limit notation and one-sided limits, the limit laws, algebraic tricks for evaluating limits, limits that do not exist, how to calculate infinite limits, limits at infinity, and asymptotes. You also need to know about continuity in the intermediate value theorem. On the actual AP exam, for the AB exam, it's going to take up 10 to 12% of the exam. And for the BC exam, it's going to take up 4 to 7%. Remember, the BC exam includes more units, so that's why this unit takes up a smaller percentage. So let's go ahead and break it down with limit notation and one-sided limits. So for limit notation, you have the limit as x approaches c of f of x. One-sided limits, you're going to have a little negative as an exponent above the c, and that indicates a limit from the left. And if the exponent is a little plus, that indicates you're only looking at the limit from the right-hand side. Now, some quick limit laws. There's the sum and difference laws. This basically says if you take the limit of a sum or difference of two functions, you can take the sum or difference of their limits separately. The limit of a product is equal to the product of the limits. The limit of a quotient of functions is equal to the quotient of their limits, provided that the limit of the denominator function is not equal to 0. Also, we have the constant multiple law for limits. That just says if you have the limit of a constant times a function, you can factor out the constant and take the limit of the function times that constant. Now let's talk a little bit about some algebraic tricks for evaluating limits. When direct substitution fails, there are three primary methods or approaches that you can use. The first one is to factor it. So for example, if we have the limit as x approaches 2, this rational function, you will get 0 over 0 with direct substitution. So if you factor the denominator and cancel out common factors, then you can evaluate the limit. The next type is multiplying by the conjugate. This often involves radical expressions where the limit again is 0 over 0. What we're going to do is multiply the numerator and denominator by the conjugate of the binomial that has the radical in it. So root x minus 2, its conjugate is root x plus 2. So you multiply that over itself and then FOIL the numerator, and you will get a factor that cancels there. And finally, multiplying by a common denominator. This is going to happen when you have complex fractions in your limit. So in this case, you want to get a common denominator of the numerator fractions and either add or subtract those, and then you can further simplify the limit from there. Now, there's two special trig limits you have to have in your back pocket. One is the limit of sine x over x as x approaches 0. That is going to be equal to 1, as well as 1 minus cosine x over x. That limit as x approaches 0 is 0. Make sure you have these two memorized. Let's talk about limits that do not exist. A limit's going to fail to exist if either the left or right side of the function are not equal as you approach the limiting value. That's going to result in a jump if the limit goes to positive or negative infinity, or if the function oscillates as you approach a limiting value. Here, as x approaches 0, you can see the function oscillates. Let's move over to continuity now. The definition of continuity: a function is continuous at x equals c. There's three conditions. 1, the function has to exist at that point. 2, the limit has to exist as x approaches that point. And 3, the limit has to equal the function value at that point. All three of those must be true. Sometimes this is condensed into the last statement, the limit equals the function value, because for two quantities to be equal, they both must exist in the first place. Discontinuities, removable. This is going to be a hole in the graph. A jump discontinuity is exactly like it says. The graph jumps from one y value to the next as x moves left to right. And an infinite discontinuity, this typically is going to happen whenever you have a vertical asymptote. You also have to remember that polynomial, exponential, trig, and logarithmic functions are all continuous on their domains. Infinite limits and asymptotes. First, we have vertical asymptotes. if the limit as x approaches c is either positive or negative infinity, then x equals c is said to be a vertical asymptote, and you'll typically graph that as a vertical dotted line. Now, for horizontal asymptotes, if you take the limit as x approaches positive or negative infinity and you get a finite value, we'll call it L, then y equals L is said to be a horizontal asymptote of that graph. For rational functions, if you take the limit as x approaches positive or negative infinity, if the degree of the numerator is less than the degree of the denominator, then the limit is going to be 0 and you have a horizontal asymptote. If the degrees are equal, then you would have a horizontal asymptote and the limit is going to be the ratio of the leading coefficients. And finally, if the degree of the numerator is greater than the degree of the denominator, then you're not going to have a vertical asymptote. The function is going to be unbounded and either approach infinity or negative infinity. You got to know the intermediate value theorem's conditions. This says that if f is continuous on the closed interval a to b and the constant n is between f of a and f of b, then there exists at least one number, we'll call it c, on the open interval a to b such that f of c equals that number. The intermediate value theorem is called an existence theorem. It tells you that a function value exists, but it doesn't tell you where it is. As we wrap up Unit 1, let's talk about some tips. You have to know the conditions for the intermediate value theorem. Free response questions, oftentimes this is one of the big 3 theorems you're going to need to know. Never assume continuity. Problems will often state the function's continuous or give you some information to know that it's continuous, but if it doesn't, don't automatically assume continuity. Also, if you need to use continuity to justify something, like the intermediate value theorem, you must explicitly state that. Make sure you're using proper limit notation. And also be careful about mixing up a limit value with a function value. If we took the limit as x approaches 1 for this graph, the limit would not exist, but the function value is equal to 1. Also, if you look at this second graph, if we took the limit as x approaches 2, the limit is 1, but the function value is 2. All right, guys, that wraps it up for Unit 1, everything you must know code for AP Calc. Hope that was helpful to you. Let me know. Take care.